Hi, my name is Camille, and in this video, I'm gonna talk about assignment 1 for COMP3132. So let's get started. Here in the first line, we are importing the library that we need for this assignment, which is NumPy, Matplot, and the model Keras, and the fashion MNIST, which is the dataset that we need. Then we are loading these data, and we are splitting it into train images, train labels, and test images and test labels. And we have here the class label, which is gonna actually map every label to know exactly what does it mean. So for question 1, what are the dimension of these variables? So basically for train images, we have 60,000 images, and each one has 28 pixel by 28 pixel. Then their labels are 60,000 label and one label for each image. And for test images, we have 10,000, also 28 by 28 pixels. And also for test labels, we have 10,000 and one label for an image. Then for the length of train labels and test labels is going to be same. I used here the length function to show me the length of these. So we have 60,000 label for the train labels and 10,000 for test labels. For question 3, please show me some of the train. I just sliced these train labels from 0 to 6, excluding 6. So we have 900302, and same thing for testing labels. Then to show the digital content of the image that has the index 5, I used here the train images, and I indexed 5 to show the data or digital content of that image. And as you can see here are the representing numbers for that image. And I just want to say something about it. When we have a lower value, which means it's a dark pixel, and we have a higher value, which means it's a brighter pixel. So for question number 5, plot the image. I just use the plot imshow, and I put the variable that I defined over there, and the color mapping is gray. And as you can see here, this is the image, and it has 28 pixels by 28 pixels. Question number 6, what is the label for index 5? The label is 2, as you can see here. For the training labels, the 5th index is actually 2, which if we map it to the class label 012, it's a pullover. And for question number 7, we have to show the digital content for image index number 500 in the testing dataset. So here we are doing the same exact thing, but for test images instead of train images. So I'm gonna skip this question. Even number 8, same thing. Number 9 is also the same thing. And for question number 10, we are importing the models and layers from Keras. Then we are defining a sequential model, call it my network, which is my network equal to models.sequential. Then we are reshaping the images from 28 by 28 pixel to one column, which is basically converting a 2D arrays to 1D array that has 784 neurons. And here we are doing this. Then we are normalizing the image by dividing it by 255, and also for the test images we're doing the same thing. Then here we are adding a hidden layer that has 512 neurons. The activation function is Rulo. Then we add another hidden layer that's also 128, that has 128 neurons. The activation function is Rulo. And then finally we have the activation method here is softmax that has 10 neuron. And we are doing that basically because we want reload to help the model to learn faster and better, and then the last layer that uses softmax to turn what the model learned into probabilities, so it can decide which of the 10 classes the image belongs to. And now for question number 17. Here we are using two different optimizer. The first one is Adam and the second one is RMS prop, and we are using also two different loss functions. So I think fashion MNIST is harder than the regular one because clothing images are more complex and look more similar to each other, while the handwritten numbers are simpler and easier to recognize. Then question number 20, I think the accuracy is different because the optimizers are different and also the loss function that were used, and this data set is harder than the one that we did in the class, so the model learns differently. And for the question number 21, the test accuracy here is 88%, and the accuracy after running the model is around 92%. So I believe, yeah, there is a slight overfitting, and that because the model performs better on training data than on test data, but the overfitting is not severe. Thanks for watching.